Hello everyone, in this video we are going to discuss the solution for multiply strings. So let's first understand the question, then we will move on to its solution. Okay, so in this question we have been given two non-negative integers called num1 and num2, which are in the string format. Alright, and what we need to do is multiply these num1 and num2, and we need to return their product as a string. Okay, and we are told that we should not use any built-in functions directly. Okay, so it means that you can't use string to integer function or to string function in here. All right, so let's first study why we are doing this multiplication of strings, and then we will see how we can do this. Okay, so let's move on. All right, so the first thing that comes into our mind that we already have integer and long integer, so why do we actually need something like to store an integer in a string and multiply them using that? Okay, so simple thing I should say is that integer and long integer all have some limitations. For example, an integer can store up to how many bytes? To about 4 bytes. Okay, this is for int, and if we talk about long, it stores 8 bytes. Okay, so if we talk about our int here, it can store up to 9 digit number, and this can store up to 19 or 18 or 19 digit number. I really don't know how big is that. Okay, 18 or 19 digit numbers. Alright, int and long can work up to that certain range, but think about a number which has almost 30 digit or 40 digits. Okay, if we will talk about these numbers which have 40 digit or 50 digits, 30 digits, like that, then it will be very difficult to store them, right? I know that in some languages like Java we have big integer library, or in Python simply we can store any amount of number or any digits of number in integer. But still, we are talking about normally, let's say we don't have access to those kind of data types. Okay, and we still need to do some this kind of uh, operation which include 30 digit number or 40 digit number. So how can we actually do that? It will be very difficult, right? We can't create a integer or long integer to store this much of integer, this much, this big of an integer. But we can certainly create a string which has length of 30 or length of 40. String of string of 30 and 40 length can exist, right? So storing that integer in instead of integer format, if I will store it into string format, surely I can store that. Or possibly if I will use an array to store every single digit, I can do that as well. Either I can use string or I can use array to store different digit. Array to store digits. Alright, so that's why we are trying to do it in the string format. Now if we will have string format, then it will have some kind of problem while we are trying to multiply them, because surely we can't do 123 string into 456 string and it will give output like that, right? So what we are trying to do is, we are given that we have stored some numbers in string and we need their multiplication, and these numbers could be very long, so we can't actually use long integer as well. So what we are trying to do is try to figure out a way so that we can actually multiply the strings and get one string as a result. Okay, so first thing we need to do is try to learn how we actually do multiplication. Okay, it may seem that it's a bit redundant because we have been doing multiplication since class 4th or 5th. All right, so it's very easy. Yeah, everyone knows that. So in spite of we know already, let's still do that. 123 into 456. We are not actually trying to do multiplication here, but we are actually trying to find, is there any kind of relation what we are doing. Okay, so in the normal multiplication what we do is we just pick one number and then pick one number from other number. This is my num1 and this is my num2, and 1 and 2. Okay, one digit from here, one digit from here, and how I multiply is, this digit is multiplied with this digit, then this digit, then this digit, some result come. Okay, then I pick this digit, I multiply with this and this, some result come again. I then pick this digit and multiply with this and this again, and some more result will come after the multiplication. And after I have multiplied with all the digit this entire thing, then I will just sum up all these results and gain some final result, right? That's how we do multiplication. So let's do one simple multiplication of these two sample input so that we can gain some significant insight on it. Okay, so this is my 123 and this is my 456. Let's multiply them. Okay, 6 into 3 18, 1 carry. 6 into 12, 12 plus 1 carry 13. 6 plus 1 6, 6 plus 1 7. Okay, and now we usually put the cross here, and then 5 into 3 13 15, 5 to the 10 plus 1 11, 5 in the 5 6, and then double crosses, and we should remove the carry, and then again 4 into 3 12, 4 to the 8, 8 plus 1 9, 4 ones are 4. All right, we get some result and then we just add them. 8 8 10 1 16 5. All right, we get this result. Let's move the carry now. So we have this result. Let's keep it here. So we can clearly see what we were doing. We picked this number, then multiply with this, then this, then this. Then we picked 5, then we multiply 3, then 2, then 1. Then again we picked 4, multiply this. Hmm. So we actually know what we are doing here, right? One thing I know now is, if I have some two numbers 1 2 3 4 5 6, what I need to do is first try to pick a value from this or value or the digit from here, from my second number, and try to pick one digit from my first number, something like this, and then we multiply. Then we move on to other digit of first number, then again same thing, right? We are doing something like this. So now we know what thing we are doing, what is it we actually doing. Hmm. Now what about these results, this, we know how we are going to travel in our. Now as we know, if we have two numbers 1 2 3 and 4 5 6, we just need to travel from right to left, right to left. All right, meaning that if these their indexes are 0 1 2, then we are going to move from 2 till 0. Okay, this is one thing we have found. Other thing we have found is we have to pick one digit at a time. So we need to pick this and this. Okay, like this. So we are going to multiply them in this order, right to left, pick one digit and multiply. Okay, so let's name them. If I will pick a digit from this number, the first number, I will call it jval, and if I pick it from second number, I will call it ival. Okay, you can name it anything you want. I'm just calling it ival and jval. If even if I switch their names now, if I call ival this number and jval this number, it won't matter, because ultimately we are doing the same thing. It will be like 123 is multiplied by 456. Okay, as we already know, 123 into 456 equal to 456 into 123. It is basically the same thing, so it won't matter, right? So I have named this jval and ival. Now this is a string, we know that, and this is also a string, we also know that. But if I will try to make some changes in the string, it will be very difficult, right? And why do I need to create my answer in result, answer in string? I've been told that I should return it in string. This thing as a result, I have been told that I should only use strings, right? I have only been told that the answer should be returned in string. Okay, so I'm going to use some loophole here. Okay, what I'm going to do is, instead of using string to calculate anything in this part, this whole thing, what I'm going to do, I'm going to use array. Okay, integer, I'm going to use integer array because these two are in string already. These two are in string, and it will be very difficult to keep maintaining my string. Okay, and if I will try to maintain these strings now, it will be very confusing as well. So instead of focusing on how to balance this string, I will just try to solve all this operation in using a array, integer array basically, and it will be very much smoother to use that. And after I will find the result, this result, what I will do is I will convert this into string, this integer into string. It will be very easy. Okay, so let's figure out how I'm going to create the result array. Okay, so we know this result is how much length this had, 5 length. Okay, and if you look closely, my num1 had length of 3, and 2 of this number is 3 also, and this was 5. Okay, so if I will do L1 plus L2, it will give me 6. The value of result was less than 6. The length of string, I'm saying. Okay, let's take some more example. Let's say 99 multiplied by 99 and 999 multiplied by 999. And why these two numbers? Simply because this is my largest 2-digit number and largest 3-digit number. If something, some way I will able to find, is there any connection between the length of this multiplication result with these two numbers, then I will be able to devise that for my own result. Okay, so let's multiply them. 81, 81, so 891, 891, 0, 0, not 0, 1 here, 0, 1, 18, 9810. These two had combined length of 4, and this also had combined length. Let's multiply them. 891, 891, 891 again, 1, 10, 19, 1, 18, 1. Okay, this had length of 5 and their combined length was 6. So I know that now the length of my result is equal to length of my num1. Okay, let me write it more clearly. Okay, so if my length of num1 is L1 and length of num2 is L2, then the length of my result will be less than or equal to L1 plus L2. That's what I have found. Okay, it won't be more than the sum of L1 and L2. This is the result that I have devised from multiplication of largest 2-digit number and largest 3-digit number. Alright, so now I know what this array size is, the maximum size it can take. I can create that. So in my sample test case, this is 3 and this is 456, so its length will be 3 also. Okay, let's write it. 123, 456. Let's create a array of result. 1, 2, 3, 4, 5, 6. Okay, this is result. All right, Hmm. I know that I'm calling this digit the this digit as jval. The digit that I'm taking from number 1 is jval, and digit that I'm choosing from this is I'm calling ival. Okay, now if I'm multiplying these two, I have to store it in this result. Okay, so for that I will also need a pointer for this result. So let's call it k. So I'm going to calculate ival first. So ival will be calculated as um num2 I minus 0 character. This is character, right? Something like this will be used to calculate ival. Okay, and why is that? Simply because this is also a character, and I'm subtracting this 0 character, and whatever value this is going to give me, this is will be in my ASCII value. So I will get this 3 is an integer. Same thing, jval equals to num1 j minus 0. Like this, I will get value for this as well. Now I have these two values. Now at what point I should start my k? K should be started at L1 plus L2 minus 1. And why is that? Because we have 0 based indexing, right? 0, 1, 2, 3, 4, 5. Okay, that's why k will start at this point. Also, one thing I will need is carry. Alright, because each time I will multiply, I will generate some carry. Okay, so I think these are the only variable that I can think of right now. So let's multiply them now. Okay, so 6 multiplied by 3, 18. 1 is generated as carry. Okay, I am multiplying this and this, and will store it at here. Okay, so if I'm making these many variables, so let's create one more. Let's call it product. Okay, and its value will be ival multiplied by jval plus carry. Okay, because let's say for this 6 multiplied by 2, it will be 12, but there is one carry, so 13. So product, right? And what this is doing is this k is stored ring what? Product modulus 10. Remainder after the product is modulus by 10. So that's it. And carry is calculated as product divided by 10. Simple maths. Okay, so that's how we are doing. So let's do this. So I was giving just an example. I haven't multiplied it with 2 yet. So after all this is done, I will move my jval to here, and I should I move ival? No, I should not move ival. It will remain till the jval, which is the end, or I should say -1, because string is also using 0 based indexing. This point is 0, this point is 1, this point is 2. Okay, and when I do this now, jval is moved at this 2 place. I should also move my k. So let's move it also. So I moved it. Now I have to multiply 6 into 2. 6 to the 12. 12 and 1 is carry. So it will generate 1 as carry. And there was 1 in the carry also. So it will add. So 3 is present now at here. Okay. And 1 is generated as carry again. Now 5 into 1. But before that, I need to move jval and also k. Alright, we have moved it. So now 5 into 1, it's 5, but we have to add carry. So 5 plus 1, 6. Oh, sorry, it was 6 multiplied by 1, not 5. So it will be 7. Right. So that's it. We have multiplied it. Now carry generated will be 0. And this jval now will point to this and k will point to this. But now jval is pointing to -1 index, which is not possible. So what this jval is going to do? Jval is going to move back to this 3 digit again. And what ival is going to do? It is going to move here 5. Okay, and carry will reset as 0. Okay, if carry had anything 1, 2, 3, anything, so what this would do, we need to do k minus minus and add 1, or add carry only. This value will be 0, but we have to add this carry at this place. Okay, we need to remember that. Alright, now ival has moved to 5 and jval has moved back to 3 again. Now k is pointing at this place, second index at result. Should I move it or I should leave it here? Definitely I have to move it back, because if I don't move it back, it will try to add something at this place, but there was not anything to add at this place, right? But now where I should actually move it to? Should I place it back to this 5th index, or should I move to this index? Let's move it to this index, but it will cause me one simple problem. Look at this carefully. When I'm multiplying it with 5, I'm actually not multiplying it with 120 with 5. This 5 is actually 50. Okay, this 5 is not actually 5, but rather this is 50. This x is not really an x, it is 0. These x's are 0. Okay, so that's why. And also, if I could, I could use some small answer and create one array for this result, one array for this result, one array for this result as well. But if I will do that now, it will consume more memory, and at the end I will have to work on this same result once again. So instead of doing that now, what I'm going to do, I'm going to just move my pointer k to this place. See, when I start multiplying with 5 now, I was already doing that in my normal multiplication. I was leaving this place and moving here. So instead of moving back to this place, L1 plus L2 minus 1, I will move this time here. So at this time, I was moving at L1 plus L2 minus 1. This time I was moving at L1 plus L2 minus 2, and this time I am moving at L1 plus L2 minus 3. Look at this carefully. I will find L1 plus L2 minus 1 is constant, and 0 minus 1 and minus 2. This thing is happening. Some more negative result is added each time. So I will call it some external force. Let's call it power factor, right? And I will say that each time my eye is moved, this power factor become more negative. And when I will add to my k now, this power factor, it will give me the right position for the k pointer, my k pointer. Okay, so that's it. Now we have devised a way so that our k will move at the right place. When I am at multiplying with this 5, I will move here. When I will multiplying with this 4, I will move at index 3 instead of fifth index. Okay, and this power factor will be decreased each time. See, negative, it is moving in negative direction now. Minus 1, minus 2. So that's it. Initially, it will be 0. Okay, let's write it somewhere. PF equal to 0. Okay, now let's multiply them. 5 3s are 15. 1 is carry. Now what will happen? This 5 should be added at this place. This. Okay, so it can't happen that product modulus 10 now, because if I will do that, this 3 will be gone and 5 will be written here. But I don't want that. I want value for 3 also. So what I'm going to do is I will add my result of k as well in this product. Okay, and I will have to just make sure that this result array initially contains all the zeros like this. Okay, right now I am just removing them because I will have to write something later on. So I will have to initially make sure that this resultant array has zeros in it. Okay, so I will write just this and I won't have to change anything. So that's it. We have now 5 here. 5 plus 3, 8, or I should say 15. 15 plus 3, 18. 8 will come here. Let me write it clearly. 8 will come here. 1 will go carry. And that's it. Now, what will happen? K will move forward. J will move forward. Now, 5 into 2, 10. 10 plus 1 carry, 11. 11 plus 7, this result K, 18. So 18, 1 is still carry. Okay, by this, and now 8 will come here. 8. Alright. Now K will move forward, J will move forward. Right. Now same thing. 5 into 1. 5. 5 plus 1 carry. 6. 6 plus. There's nothing here. 0. So I will write 6 here. That's it. Now K will move forward. J will move forward. As J is not pointing to anything now, it will move back and it will make K move back to this third index, and it will make I to move to fourth digit, the digit 4, not the fourth digit, digit 4. All right. Hmm. Now we should multiply with, start multiplying with here. And one more thing, carry will reset to 0. Now 4 multiplied by 3, 4 3s are 12. And we have 8 here, so it will become 20. So now 20 is present. So at this place 0 will come. Okay. Now 4 into 2. 4 2s are 8. 8 plus 2, 10. Okay. But before this, I should have moved it here and here. That's better. Yeah, I should have done that. Now I should have multiplied. Yeah, let's multiply it again. 4 into 2, 8. 8 plus 2, 10. 10 plus 6, 16. And 1 goes carry. 6 will remain as it is. Okay. Now K will move forward, J will move forward, and 4 into 1, 4. 4 plus 1, 5. 5 plus 0, also 5. So 5 will come here. And now J will move forward, I will move forward. Now J is not moving, pointing to anything else. It will move back. Okay. K should move back as well at second index. But now see very carefully. I val is not pointing to anything now. Now what this mean? This means that our multiplication is done. When my I val has reached the -1 index. Remember, this was my 0 index, this was 1 index, and this was second index. Okay, so that's why it is not pointing to anything. Now this means is my multiplication is done. Okay, if my multiplication is done, then this resultant array will contain the result. As you can see, it contains 56088. Also this 0 index will contain 0. Okay, now I just need to convert this resultant array into a string. Okay, now some of you may be saying, let's go travel through this array one by one and pick one by turn each digit into character and put it into a string. Okay, let's do that. 0 5 6 0 8 8, but we have this additional 0. We only want this. We don't want any leading zeros in the string. So if we don't want that now, we need to remove the leading zero. Okay, so how we can do that? Okay, the first idea that comes to mind is just put a check if res I equal to 0, continue, else add it to string, add element of this to string, or res I in the string, like that. Okay, convert it into string and put it in the string. That is my answer string. But if I will do that now, it will create problem. See, I have, let's do a small diagram. I 0, this condition will run, it will continue, won't add to string, 5 add to string, 6 add to string, 0. Okay, doesn't this condition validates? 0 won't add, this will add, and this will add. Now we have a number, but it is missing 1 0, which should have come here. At this place 0 should come, but we have lost it because of this condition. So we need to put one more check so that this 0 is not lost. Okay, so before I will start my loop now, I will make a variable called flag and I will keep it as false. And what this is going to do, this is just going to tell me that if I have encountered any non-zero integer or not. Once I have encountered a non-zero integer, it means one thing, that now whatever 0 will come, I will have to include in my answer. So I will just do it like this. And in the else case, what I will do, I will say flag equal true, meaning it has found a non-zero integer. Okay, and here I will add one more condition, flag equal to false, meaning at this time we haven't encountered any leading zeros, sorry, non-zero integer. Okay, so that's it. Now there is only one condition remaining that I will tell you while we are coding. Okay, so let's try to implement our approach into code. All right, then let's code it now. So it's very simple now. So first thing what we are going to do is have our length of string 1 and string 2, or num1 num2. Okay, so l1 equals to num1 dot length and l2 equals num2 dot length. All right, now we have to create vector for vector int for our result, which is equal to size of l1 plus l2, because our result can vary till the length of l1 plus l2 at max. Okay, now we just need I. And now what is I? We were talking about I val and j val, and now we are talking about I. It's nothing but the pointer which is telling us where is the I val. Okay, so let's see again. I was using something like this. I Okay. So mm, this I val is nothing but index here. 1 2 0 1 2. This is nothing but that index. Okay, I and j will be those indexes. Okay, I1 equal L1 minus. Okay, now I have used L1 minus 1, and in the question that I have just explained, I have used I as L2. Okay, it doesn't actually matter what you use here. You can use L1 or L2 because we know if we multiply x by y, x with y, or y with x, we will get the same result. This is the same case here. It doesn't matter if you use num1 to multiply with num2 or num2 to multiply with num1. You will get the same result. Okay, so now we know I. You also have to create a power factor so that when I shifts, k also shifts by some distance. So for that, we were using power factor. Or okay, now we are going to use while loop. I is greater than equal to 0 because we are trying from right to left, and our indexing starts from 0. Okay, so I greater than equal to 0. That's it. Now first thing what we are going to do is calculate I val. So let's calculate I val. So I val will be equal to num 1 I minus 0 character. This ith character from num1 minus this will give me the ASCII value will be subtracted, and whatever result I will get as an integer. So that's it. That's how I'm going to get my I val. Okay, now I will need j, which is similar to this L1 2 minus 1, and I will also need k, which will start from L1 plus L2 minus 1 plus my power factor, which will always decrease. Okay, let's minus this. Why? J is greater than equal to 0. Okay, at this place I will also do this carry greater than 0. And now why is that? Simply if the number ends but there is still some value left in the carry, it means that I will have to put it in my answer. Otherwise, that value for the carry will be lost and it won't be utilized. So I have to use this value of the carry. That's why I will have to put this check here. Okay, so that's it. Now I will have to create carry also. So let's start it with 0. Okay, now I will do the same thing for the j val, but now here, as I said, that carry, if there is some carry left, then I will have to do some work. Because of that, I will have to put some condition also. If this situation is true, meaning that if my j is valid, then only my num2 should what it should do. Okay, it should be j val as well. J val equal to j greater than this. If this is true, then only do this, otherwise give it value 0. Now think about it. If my carry is greater than 0 but this becomes less than 0, it means it will become -1, and there's no index which is -1, and because of that -1, This will give me error, array index out of bound. So I have to put a check here. Okay, now I have to do product, and product is equal to ival multiplied by jval plus carry plus result of k. Okay, result of k is equal to product modulus 10. We have already discussed this. And my carry is equal to product divided by 10 and j minus minus and k minus minus as well. Okay. I forgot one thing. I forgot to do I minus minus. Yeah, I haven't done that. So that was all the calculation needed for calculating my result array. Now I just need to create a string. My answer string, basically. String str. Let's put empty string here. Okay. I will also need a flag, boolean flag, which will be initially false. And what this flag was telling me? This flag was telling me that the while we are traveling, we haven't found non-zero element yet. So for int, let's use for each loop. In result, if flag is false and my element is also 0, meaning this is my leading 0, then what should I do? I just need to continue. Else, what should I do? First thing, I should make flag true. Second thing, I should add this element to my string. But for that, I need to convert my element into a string. But I don't know how to do this. But I definitely know without using library toString, library function toString, I can do just this. ASCII mathematics. The same thing that I have done here, I will use it here. Simply 0 plus LE, and that's it. This will give me nothing but turn it into this ASCII for this plus element, and this will convert everything. Now I told you all the condition except one condition. Let's discuss it. Okay, so I told you how this string is created, right? String is initially empty string. Okay, now suppose instead of giving any number like this, num1 equals to 756, and I suddenly gave you num2 as 0. Now what will this give me? Simply anyone can say it. It will give me 0, right? But this 0 won't be shown. Why? Let's see. Now look carefully in this condition. Okay, I was already skipping when I got the element as 0, but as my result is 0, what is going to happen? It will consider all the zeros adds the leading zeros, and till the end this flag condition will not be set true. So because of that, this string will remain this empty string. And because of this, if I will try to do this now, num1 equal to 756 and num2 equal to 0, it will give me wrong answer. Okay, now you know that even if num1 is 0 and num2 is 756, it will be the same thing, right? No matter if num1 is 0 or num2 is 0, we will get result as 0. So instead of doing anything here now, doing so much calculation, let's put one condition up here. And what we should write, num1 equals to 0 or num2 equals to 0. If this is the case, it means that my answer will be created as 0. So instead of going through all this calculation, I will just return 0 string from up here. I don't need to do anything here. If this is empty string, let it remain as empty string, and I will just do my work up here. It won't do all the calculation. If one of the string is 0, then I will just return the 0 string, nothing else. Okay, let's run it now. Okay, I was using test case. So let's write 1 2 3 and 4 5 6. So it haven't removed my 0. Maybe I have forgotten to make flag true. Okay, I have used assignment operator instead of equality operator. Let's run it now. Okay, now it is working fine. Now we got the correct answer. Let's submit it. So all the test case passed, which means our code is correct. And now you also know why we are trying to multiply strings. Okay, so that's all for the solution of multiplication of strings. And that's all for the solution. And I'll see you in the next video with a new question.